Hi mathematicians. Today we are working on Unit 2, Lesson 7, which is titled Properties and Strategies. And our focus today in our learning is to use the commutative and associative along with the distributive properties to compute mentally. So just remember our focus today is that mental part. We want to really work towards adding and subtracting numbers in our heads so that we can be more efficient and not have to use paper and pencil, because in real life you don't always have a pencil and paper to use. So sometimes you only have your brain. So we want to make sure we exercise that and use that capability. So with that being said, we want to focus on the commutative and associative properties first. These two are used together a lot of the time because the commutative property is the fact that numbers can be added in any order. So example, 4 plus 6 equals 10 and 6 plus 4 equals 10. It doesn't matter which way you add 6 and 4, it's always going to equal 10. That's the commutative property of addition. The associative property of addition is when numbers can be grouped in any arrangement. So that means that you could do, like for example, 4 plus 6 plus 2 is going to equal 12. But if you did 4 plus 6 first and then added 2, you're going to get 12. But then if you also did 6 plus 2 first to get 8 and then added that to 4, you'll get 12 still. So it doesn't matter which numbers you add together first or how you group those numbers, you're still going to get the same sum. So let's look at that same skill with larger numbers here. So we have our first problem here that I'm focusing on is right here. And we have 500,000 plus 25,000 plus 38,000 plus 75,000 plus 50,000. Now, typically what we would do is we grab a piece of paper and a pencil and we'd write them all down and we add them up, starting in the ones place and carry when we need to, and so on and so forth. That's the algorithm. Those are the steps of addition. However, we could use our brains to help us be even more efficient than that, because if we look closely at these numbers, there are things that we can group differently or a different order in which we can do things in order to add these together. Okay, so for example here we have 50,000 and 50,000 add up together for 100,000. And then if you look even closer, we have 25,000 and 75,000. So I'm just trying to find groups that add up to 100,000 so that I could easily add those in my head. And then we can add 38,000, and that'll give us a total of 100, 200, and 38,000. So our answer here, or our sum, would be 238,000. Okay, now let's go a little deeper and look at decimals. We've been working with decimals. Okay, so we know decimals can add up to equal 1 whole or 10 or something like that. Any round, nice, even number that's easy to add in our head. So let's look for patterns of 1 here. Right off the bat, I see 5/10 and 5/10 would equal 1. I have 25/100 and 75/100 equals 1 whole. And then I have the 38/100. So that would give me a total of 1, 2, and 38/100. 2 and 38/100. Okay, and then just for one more example, let's look at fractions just to see. Here we have fractions that all have different denominators. So if you notice, we have fifths, fourths, 17ths, fourths, and fifths. So I know that if I combine those ones that have the same, like the fifths and the fifths, I don't have to find an equivalent or a common denominator among all of these, which would be really tough. I could use my brain and I can say, okay, well, 2 and 4/5 plus 1/5 would equal a whole 3, because 4/5 and 1/5 equals 1, and then I'm adding the 2. So that's 3. Now here I have fourths. I have 3/4 and 1/4. That equals 1 whole. And then look at that. I have my 5 and 17/100. So looking for these patterns can really help us, because that problem could have taken us a really long time trying to find a common denominator. But by doing this commutative and associative property and using these tools in our toolbox, we were able to do this really fast mentally. So 3 plus 1 is 4, plus 5 and 5/17 would be 4 and 5/17. So hopefully at this point you can see how the commutative property and the associative property can help you mentally group numbers and regroup numbers and add them in different orders so that you can find those easy groups that are easy to add mentally, making you more efficient as a mathematician. Now let's look at the distributive property. So the distributive property, here's the definition over here. It says the sum of two products that share a factor. Okay, so let's think about this. The sum is the answer of an addition problem. Two products means that two numbers are multiplied together because a product is an answer to a multiplication problem. They share a factor. A factor is a number in a multiplication problem, and they can be simplified into just one pair of factors. Okay, so again, we have those numbers in multiplication problems. So here, if we look at this, we have 7 times 25 plus 7 times 25 plus 7 times 75, excuse me. So this is our original problem right here. Okay, and I want to show you how we can regroup these numbers to make it easy to add, because what we would typically do is do the multiplication here first, do the multiplication here first, and then add those two products together. That could take a really long time, plus most of us would need to use pen and pencil or paper with that to find the answer of that. But let's see how distributive property can help us break that down mentally. So notice that these both have a factor of 7. Okay, so if we pull that factor out of those and we keep it by itself, that'll leave us with this 25 and 75 to add together. So here we're going to take that 25 and that 75, we're going to add those together. We're going to multiply that sum by that one factor that we pulled out. Okay, so what that tells us now is 7 times 100, because 25 plus 75 is 100. 7 times 100 is easy to do in our heads, so that gives us a total of 700, where we probably would have never been able to do this part mentally with this type of problem. But thankfully, since we know the distributive property, we can then use our brains to break this apart and add mentally without having to get paper and pencil. So in your student activity, you have 2 pages that will allow you to practice these skills. So the first one is page 51. And that's this one right here. This will give you lots of opportunities to practice the commutative property and the associative property in different situations. So you'll have some whole numbers, some decimals, and even some fractions. And then notice they even take you into different forms of those numbers. Here, word form, expanded form, and some fractions to practice. Okay, so great idea to go back and practice those to make sure you understand them thoroughly. If you don't have your student activity notebook with you, you could always just recopy these into your math notebook and use those as examples. You don't necessarily have to have this page with you. Okay, so let's go ahead and close that for a little bit. And let's blow this one up, because this one I want to look a little bit closer at. This one's talking about the distributive property. So let's do a few of these examples together. So this one says, this actually is the one that we just did on the other page. So let's look at number 9. So number 9, we have a factor of 9 that's used in both of these groupings. So let's pull that out separately. And then we're going to add these other 2 factors together into a group. So then we're going to multiply that by the sum of those other 2 numbers, which is 800 plus 200. Again, using our mental math here, we know 800 plus 200 is 1,000. Okay, so now we have 9 times 1,000, which we can easily do in our heads, and we know that that is 9,000. Okay, so there's one example of how to do that mentally. Okay, let's look at a couple other examples here. Oops, sorry about that. Let's go back. Okay, I don't want to undo everything, so I'll just figure out how to erase this. Let's see if I can do that. Nope. All right, so here are a few more examples. Let's look at number 13, because number 13 is a real-life example of how you would use this skill in your life. So it says, use the distributive property to help you find the combined area of these rectangles. So we need to find the area of this rectangle and the area of this rectangle, and then combine those together for a total. Okay, so if we wrote that out, it would be 199 times 10, because we know area is length times width. And then we would have to add that to this rectangle over here, which is 101 centimeters times 10 centimeters. Okay, so here we notice we have a 10 and a 10, so we can pull that out of our equation and multiply that by the other factors, which is 199 and 101. So I know if I take 1 away from here, that leaves me with 100, and if I add that 1 over here, that gives me 200. So 200 plus 100 is 300. And I want to multiply that by 10. Now we know multiplying by a power of 10, we add that 0. So this is going to end up with a total of 3,000 centimeters squared, and that would be your final area. So see how quickly you can do that in your head if you're able to use these properties to help support you. It's really incredible what your brain's capable of. So keep practicing and you will get it. See you tomorrow, mathematicians. Have a great night and study hard.